Hi everybody, today we're going to do all the things with inverses. The idea is that you already sort of know this stuff, and this is really just a reminder. So let's start with what an inverse really is. An inverse just undoes something. So like adding and subtracting are inverses. You really don't want to think of them as opposites, even though adding and subtracting are opposites as well, but this is just a relation. So some sort of arithmetic, square, cube, anything, that undoes or reverses another relation. So square root and square, cube and cube root, multiply, divide, add, subtract, these are all inverses. And the inverse is used, like if we're calling it the function capital R, the inverse has a little -1 power. This is confusing because that's also a reciprocal, so it is definitely confusing. So that's the inverse notation. We don't often do a lot with reciprocals and write them that way, so that's kind of the good news, is that you really won't run into that as often. Now your inverse is as simple as switching the x and y. So if they give us a bunch of points, to find the inverse, you would just switch the x and the y. That's all that there is. So we switch the x and y, and basically kind of every meaning of it. I get the idea. I don't know that we need to do all of these, so we'll just stop there. So that's all we have to do to find the inverse. We'll go through a bunch of examples graphically and algebraically here in a minute. Now, a one-to-one function, one-to-one is a little bit pickier. Basically, you have to make sure that the relation, so whatever we're dealing with, we don't want to call it a function because it might not be a function, and the inverse are actually functions. And the easiest way to do this is with a graph. So if you remember the vertical line test, take your graph and you do the vertical lines, you know, these vertical lines, and if that vertical line only touches it once, touching the graph in one spot, then you know you have a function. Now the horizontal line test is used to see if the inverse is a function. If they pass both of them, then it's one-to-one. So let's just go through some of these. So we got to test the vertical line, and we have to test the horizontal line. So vertical line test, horizontal line test. So horizontal line test, yes, that passes. Vertical line test, yes. So this one is a function, yes. This is one-to-one. So remember, the vertical line test tests that particular graph. So the vertical line test, so this particular graph is a function. But if we do the horizontal line test, its inverse is not. So this means it's not one-to-one. So with this one, vertical line test, yes, we're good. Don't trust your graph too much. These are not straight up and down or absolutely horizontal. They do have a kind of a slant. So this one is also yes. This is the cube root graph. This is not one of our parent functions, but that's what it is. Let's see. Vertical passes, horizontal passes, so this one's also yes. Now this line I think is hard to see. It's this line right here. It's this actual line at y equals, looks like 3. And of course, this one's going to fail. It passes the vertical, but it fails the horizontal. So this one is not a function. Now, the fact that it's not a one-to-one function doesn't really mean much. It doesn't mean we can't graph it. It doesn't mean it doesn't exist. It has all those things. We can still have an equation for it. Obviously, we can draw the graph. It's just not one-to-one, a very specific type of relation. And for this last one, you can already see that it's going to fail the vertical line test, so this one is also not one-to-one. So let's get into more specifically with inverses. To write the inverse, if the name of the function is f, remember that -1 power is what we use for inverse. So this would be the inverse of f of x is how you say that. And to find the inverse, here are the directions right here. So they basically spell it out for you. So we're going to switch x and y. Then you solve for y. Please don't leave it y equals. You have to rename it f inverse, or f to the negative 1. Now, before we can determine if we have an inverse, we have to sort of picture the graph. Does the graph of this, whatever function we're dealing with, does it pass the horizontal line test? Check that first. If it doesn't have an inverse, then we don't need to find it. So we're doing a lot of work that doesn't need to be done. So let's work smart. So for this first one, it's definitely just a regular line. It's not a horizontal line. It's just a line with a slope of 4. So this one will have an inverse. So we're going to switch the x and y. So this, remember, is really your y right here. So this becomes the x. So we have x equals 4y minus 8. Add 8 to both sides. Divide both sides by 4. Now you can divide the whole thing by 4. You can individually divide each part by 4. Completely up to you. So you can write this x over 4 plus 2 equals the inverse. Remember, you got to change the name. Or, if you'd rather, you could write it as x plus 8 over 4. It's not as simplified, but the calculator, when we go to graph these, the calculator doesn't care, so it's fine. Now, for the power of 3, the power of 3 is a good one because we know that the domain and range is always all real. So this one is always going to have an inverse. It's the power of 2, and the absolute value we have to be careful of. So we're going to switch this x and y. So x equals 1/2 y to the third minus 1. Add 1. I'm going to multiply both sides by 2. So be careful with this. You do want to make sure you use parentheses. So this will be 2x plus 2 equals y to the third. And then to undo that, the inverse is the cube root. So we have the cube root of 2x plus 2, and change the name to the inverse function. Now, for number 9, if we think about what this graph looks like, we know a lot about it. This is really going to test your parent functions and your transformations. We know that it moves left 4 and up 6, and it's just a parabola. And so it fails the horizontal line test. So we're going to say no inverse. Fails the horizontal line test. Now, if you're not good at that graph, throw it in the calculator. Whereas like this graph, you're probably not as good at it. This graph actually passes the horizontal and the vertical line test. If we just think about the parent function, it's fine. Everything works on it. So we are going to have an inverse here. So let's switch the x and y. Now, for whatever reason, these have a tendency to be tricky. I'm going to put that x over 1, and then we're just going to cross multiply. It doesn't really matter which direction you go first. I like to have my letters on the left, so I'm going to go in this direction first. And so this is x times y minus 8. I'm going to use parentheses, of course. The other side is a 5. Divide both sides by x. Why distribute? This doesn't make any sense. I don't want to have x twice. So now y minus 8 is equal to 5 over x, and then we can just add 8. So 5 over x plus 8 is the inverse. And those graphs we're not really super good at yet. We will spend a lot of time just focusing on those rational graphs. Right now all you have to be able to do is the algebra behind finding the inverse. Now square root, you know about this graph. Doesn't really matter, right? So if we move it and then move it down, and then if we reflect it like this, so this piece wouldn't be there. This definitely, square root has the pattern that passes both horizontal and vertical line tests. So we're good there. Switch the x and y. So x equals the opposite of y plus 2 underneath here, and then the minus 7. So add the 7 first. Now don't just square both sides. We have to take the opposite of both sides first. We got to get rid of this negative 1. So we're going to multiply both sides by negative 1. And again, parentheses will be super helpful. So we have negative x minus 7 equals the square root of y plus 2. And now you square both sides. You can leave it like this if you want to. So the inverse, these boxes are little, is in the parentheses negative x minus 7 squared. Oh, and then of course we got to move this 2 over, plus 2. The plus 2 actually sticks out. Absolute value is one that is kind of like a parabola in that we have to pay attention to what the shape looks like. So if we think about what this would look like, we would move it left 1, it would flip over, and it would have a vertical shrink. So this fails the horizontal line test. So we would say no inverse because it fails the horizontal line test. So be careful with powers of 2 and absolute value. Everything else is probably going to be okay. Now you can graph those in the calculator if you like. So let's talk more about these graphs. We can also do an inverse graphically. They're inverses, so we have 2 functions. Our inverses if they reflect over the line y equals x. So y equals x is that line that goes diagonally through the grid, 0, 0, 1, 1, 2, 2. So this is the line. I'm just going to put that on there. And so you'll see here in a second when we draw these graphs that these 2 graphs that we're going to draw will fold on that line and they will match up. Now obviously we're not going to be able to fold it on the screen, but if we had a piece of paper we could fold it and see that. So this is a line that's not a horizontal line, so we know it's a function, much like number 7. So let's graph this line. I'm going to graph it in red, so I'm going to graph this one in red. And so we're going to go down 6 and then up 3 over 1. It's hard for me to draw a straight line sometimes, so I have to do a lot of points. So this is our function. So we're going to switch the x and y. And then we get x plus 6 equals 3y. And because I have to draw the graph, I'm actually going to come up with a slope and a y-intercept. And it's easier that way. So we have x over 3, sorry, plus 2. This is our inverse. I'm going to graph the inverse in green because I've made blue my line of reflection. So this one has a slope of 1/3, and we start up 2. So up 2, we go up 1 over 3. You can see that one also has a point on the blue line, which is a good sign. And so that blue line is where, if you were to fold it, the red and the green lines would match up on top of each other. We'll go through a few more graphs here in a second. Now I want to do this algebraically. To verify that you have inverses, you have to do composition. So if we have 2 functions, let's say we have f of x and g of x. These are going to be inverses if we take and put g of x inside f, and the answer gives you the letter x. And, not or, you have to do both if we do the composition the other way. Put f of x inside g of x, and the answer gives you x. Not 2x, not 1 over x, no numbers, just x, assuming that your variable's x. All right, so I'm going to do f of g of x first. I'm a little bit worried about some space, so I'm going to come out here. So what that means is take g, take all of this, and put it right there, right on the top of the fraction. Who knows what we get? We'll see what happens. I'm going to use parentheses because I just think that that's a little bit easier when you do substitution. And right away you can sort of see that we have a lot of things that undo each other, like the positive 7 and the negative 7. So now we're left with 2x over 2, and those cancel, and so we do get an x. Now that doesn't mean it worked. We have to do the other way as well. G of f of x. These have a tendency, when you write them down, they look crazy, but things start crossing off and canceling. So they usually work out pretty well if they are inverses. So now we're going to go the other way, meaning this whole fraction has got to snuggle right next to that 2. So we're going to have 2, and again, I'm going to use parentheses, the fraction, and then the plus 7 sticks out. So you can see the 2's cancel, and also you can see the 7 and the negative 7, but I'll rewrite this. So we get x minus 7 plus 7, and those are 0. And so, yes, these are inverses. Square and square root, a lot of times, are inverses. Sometimes the number's in the wrong spot, so don't just assume when you see the symbols that they're going to automatically be inverses. They could have an arithmetic mistake somewhere, and just to sort of trick you. So we're going to do f of g of x. It doesn't matter which one you do first. Please label what you're doing. That way I know that you know what you're doing. So we're going to take g and put it inside this. So we're going to square it. And again, I'm going to use parentheses. So we're going to start with something squared. Our something is the square root of x plus 5. And then the minus 5 sticks out. Well, power 2 and radical cancel each other out. So we have x plus 5 minus 5. So that gives you x. If we go the other way, g of f of x. So we're going to start with g, which means the square root of something plus 5. And our something is going to be this x squared minus 5. 5's add up to 0, and the square root of x squared is x. So this is a yes. Now for this, the work is your proof. You can't just say yes or no. You need to show the work. That's proof that it works or doesn't. So here we're going to put all this together. This is really going to test your graphing ability with these transformations. Now, we did not do cube root as a parent function, so if you need to use your calculator to draw this one, that's perfectly understandable. So if we put this in the calculator, we're going to have the points negative 1, 1, 0, 2, and 1, 3. So I'm going to graph this function, and then we're going to find the inverse, and we're going to graph the inverse, then we're going to do the composition. So we're going to go through all of this again. So we first draw our function, just because we have to see if it actually passes the horizontal line test. So you want to do that first. So negative 1, 1. And I know that sometimes you're not as familiar with these because this is not a parent function, but this is what the cube root looks like. So there's our original. So it does pass the horizontal line test, which means we could go ahead and find the inverse. So then let's find the inverse, switch the x and y. X equals the cube root of y plus 2. So x minus 2 is the cube root of y. And then we take and put both of these sides to the third power. So we have x minus 2 to the third power equals our inverse. Now you should be able to graph this without the calculator. This is the cube, so we know the parent function, move to the right 2. So if we move this thing to the right 2, we know that the pattern is right 1, up 1, and left 1, down 1, and it has that same kind of S sort of feel to it. And then you can see that this does seem like it reflects over the line y equals x. So you can verify that graphically. Now algebraically is what we just did. Now my names are not f and g. My names are f and f inverse. So I'm going to take the inverse and put that inside the function first. Notice how I've written down what I'm doing. Please do the same thing. So I'm going to start with the function, which is the cube root of something plus 2. And our something is this x minus 2 to the third. Well, the powers cancel each other out, and the negative 2 and the positive 2 add up to 0. So that actually worked. Let's see if it works the other way. This will also help you figure out if maybe you have a mistake somewhere. I'm not saying they always work. That's when it starts to get tricky. We showed on the graph that it does work, so if the algebra doesn't work out, then we know you have a mistake somewhere. So we're going to take the inverse, which says something minus 2 cubed. And we're going to put the function back into it, which is the cube root of x, and then the plus 2 sticks out. So the 2's add up to 0. The powers and the radical sign there cancel each other out, and we do end up with the x. So it actually worked out pretty good. So let's just do this one more time. Now this one, you should be able to graph without the calculator. That's really what this is a good kind of review of all the things that we've done with these graphs. So this one, graph it first. Now they have restricted the domain, which is going to help us. So we know this thing moved left 4 and down 2. We also know by the fact that we're not allowed to go to the left. We have to go greater than -4. So we're only allowed to go to the right. So we don't have a vertical stretch or shrink. So right 1, up 1, right 2, up 4. And this is not an entire parabola. It's just this piece of it because they've cut the parabola in half by restricting the domain. So this one actually works. I was expecting a power of 2 to not work, but it works because they restricted it. So now we're going to find the inverse. So x equals y plus 4 squared minus 2. Get this 2 over here. And take the square root. So we have the square root of x plus 2 is equal to y plus 4. And now subtract the 4. So the square root of x plus 2 minus 4 on the outside is your inverse. Again, you should be very good at graphing this without the calculator. You know that this part is left 2, and then this one is down 4. So left 2, down 4, and you should also know the pattern. Right 1, up 1, right 4 from that original point, up 2. This is the inverse. The line y equals x, you can see, really just sort of cuts the space directly in half. And if you were to fold it on that line, they are actually inverses. So that's good. So now we got to prove that we're correct algebraically. Again, I'm going to do it in the same order. I think it helps if you're not random, if you're intentional in your work. So I'm going to take the function and put the inverse in it. So the function, something plus 4 squared minus 2. And our something is this whole square root. I don't know if I gave enough space. X plus 2, the minus 4 out here. These cancel. So now I have the square root of x plus 2 squared minus 2. So these cancel. And then the 2's are going to add up to 0. So it did work. Let's do it the other way. Start with the inverse and put the function in it. So the inverse is the square root of something plus 2 with the minus 4 out here. And the function, of course, not enough space, bad planning, x plus 4, quantity squared, I'm going to squeeze it in there, you know I am, minus 2. So the 2's cancel. So now we have the square root of x plus 4, quantity squared, minus 4. Power of 2 and the radical sign are inverses. X plus 4 minus 4 leaves you with an x. So there was a lot here. This is really all the things of inverses that you did in Algebra 2. So hopefully this helps you remind yourself of all the different things. Horizontal line test. If it doesn't pass the horizontal line test, then there's no need to find the inverse. So remember that. Try the homework and make sure you bring all questions to class or to the office hours on Wednesday. Or email me or send me a message on Remind if you have questions or issues with this.